Let's start with this chapter with the concept of errors and approximations. All right. See, when we talk about errors and approximations. All right. See, errors and approximations, we pretty much approximate in everything, I would say. Like if you have 19.5, we approximate it to 20. Correct. If you have 5.7, we approximate it to 6. Or if you have something like 8.1, we approximate it to 8. Right. You must have heard about so many cases where we take pi, approximately take pi as 3. Well, approximation, isn't it? Now, errors is something what we need to be careful about. All right. Now, whenever we do any math, any sort of a math, there might be one or two decimal errors. I mean, I would not say for every problem, but in certain problems or certain cases. All right. So, these errors we can calculate with derivative. How we are going to calculate? Let's look into this right now. See, what we know is dy by dx, we can write it. Correct? So, when you are going to write dy by dx, say you have delta y. Okay, assume. Now, delta y by delta x, when you have to calculate this one, so what we can write, delta y is going to be some error or some approximated value, whatever it is. All right. So that particular error, what you are trying to figure out, or that approximated value, what you are going to find out, that you can write this one as dy by dx, correct? Or mathematically, when you are writing this, the approximated value will be delta y is equal to dy by dx into delta x. So this is going to be the formula. Now I just gave you the formula. Now let's backtrack and try to understand what is the meaning of this particular formula. All right. So what we are trying to do here, delta y is equal to dy by dx into delta x. Correct. So as delta x tends to 0, delta x becomes dx. So dx cancels out. In the sense here, what we are trying to do is graphically, if you try to understand this one. Again, I tell you, graphically, if you try to understand this, see what you can have. Assume you have the y-axis and x-axis, and there is some graph like this. Okay, or let's make it even more steeper, maybe something like this. Fair enough. Now, at this point, you want to calculate the slope or whatever it is. Some value maybe you are trying to calculate, like y is equal to f of x, right? Say you know the value of x, you're trying to find the value of y. Okay, basically some sort of a mathematical calculation you're trying to do. So first thing what we'll do, we'll write a tangent. So at this point, you are going to draw a tangent, because if you remember last year's physics, also we have done a lot of math in this one also. So last year physics, you would have understood that the slope of a line is nothing but the derivative. Correct? So at this point, we are trying to calculate the derivative. All right. Now, to get to this point, so we can say that I can come at this point and you can draw a tangent like this. Or you can take another point somewhere over here and you can draw a tangent like this. See, whatever it is. But then there is some sort of an error here, correct? The actual value is different. The actual value or the value what we are getting is different. So there is some sort of an error in the function, isn't it? So, or you can say that we are trying to approximate the value of the function. Fair enough. So, how are we going to use the derivative as to calculate the errors and approximation? So, the geometrical interpretation is going to be this one. So, there is a small change here, that is basically delta x. All right. Now, what's going to happen as your delta x becomes smaller and smaller and smaller? it's going to become dx. So delta y is equal to dy by dx into delta x. As delta x tends to 0, delta x and dx will be the same. So you'll get dy is equal to delta y or delta y is equal to dy. So this is basically the meaning of the formula. In the sense, this delta x is the error, correct? You're trying to minimize the error in such a way that the error in the value of y will also start to reduce. Clear? So that is the meaning of this particular formula. Y is equal to dy by dx into delta x. Now in the next video, we'll do few problems, because when you do the problems, you will understand like, oh, this is what it is and this is how we are going to solve it. Because when you understand the application, that's the whole point of this chapter, application of derivatives, right? So once you apply the formula, then you will understand how to, or how exactly this formula is going to give us the value. Clear? So in the next video, we'll start to solve few problems based on this one.